How many different remainders can result when the 100th power of an integer is divided by 125? So for this problem, we're going to want to use Euler's totient theorem. This is a theorem that sometimes comes up in number theory. So what Euler's totient theorem says is that we're going to let a and m be relatively prime integers. And we'll assume that m is positive. So what Euler's totient theorem says is that if a and m are relatively prime integers, then a to the totient of m is congruent to 1 modulo m. Remember that the totient of m counts the number of positive integers less than or equal to m, which are relatively prime with m. And so we're going to use this theorem to basically get an instant solution here. So we're going to look at the number a to the 100 modulo 125. So we're going to think of m as 125. So for this problem, we have two cases. We're going to let this integer be a. So the two cases are as follows. If 5 divides a, so if a is divisible by 5, then we cannot apply Euler's totient theorem because this theorem requires that a and m are relatively prime. However, what happens here is that if a is divisible by 5, then clearly the 100th power will be divisible by 125. So if 5 divides a, then a to the 100 will definitely be congruent to 0 modulo 125. This gives one possible remainder. On the other hand, if 5 does not divide a, in other words, a is not divisible by 5, then a to the totient of 125 is congruent to 1 modulo 125. However, it helps here to know how to compute the totient of a number. Totient of 125, this is equal to 125 times 4/5, which is 100. So this means that a to the 100 is always going to be 1 modulo 125 whenever a is not divisible by 5. This means that 1 is a possible remainder, and it's the only other possible remainder. Therefore, the number of different remainders is going to be 2, which is choice B.